All right, let's try this. Okay, so let's do this problem. Let's say that, let's define, I'm gonna do this a little differently than the book does. Let's define this as g of x is the inverse of f of x equals, let's do this one, how about x cubed plus 2x minus 1. Okay? So let's find okay. What about that?
So first we just make that x to y, switch them around, solve for y, solve for y.
Okay. Remember what we ended up talking about yesterday?
With
Right.
having to delete half of it,
Say it again.
with having to get rid of half of the graph. Like that whole.
No. That was just, so at the very end, right? We did our whole kind of review of inverse functions, right? But then at the end, we said something about calculus. We said this, right? We said.
It was the equation where it was like
Oh.
1 over
Wait, just right click right here, right in the middle.
Right click.
Yeah, but I don't want to have to do this for every one of them.
You can probably set a default background. So right click in the middle.
Hang on, we gotta pause this. This is not gonna work. I'm now recording, but I don't know that I can necessarily have a Khan Academy voice. I think I just gotta be me.
Oh, please.
Okay,
Sounds
so.
like a robot.
Can a robot commit suicide?
Probably. It's AI.
It's AI.
Okay, so we said then, if, remember we said yesterday, so same presumption, let's say g of x is the inverse of f of x, right? So then g prime of x is equivalent to 1 over f prime of
G of X.
g of x, right?
Oh, yeah.
Okay, remember this? All right, so that gives us something good here, right? Because g of x and f of x are inverses, right? Well, I don't really want to calculate the inverse of f of x. That's kind of hard to do, right? If I'm going to think about the process there, right? If I'm going to flip x and y and solve for y, that's not easy to do, right? Okay. So it'd be much, much easier for us here than trying to explicitly calculate g of x, to instead write this as the reciprocal of the derivative of f of x at g of, see what I'm saying, at g of 2, right? Okay, because we know that g of x, let's just use our previous result, right? G prime of x is going to be 1 over f prime of g of x, right? So that implies that g prime of 2, you fill in the blanks, g prime of 2 is 1 over f prime of what?
G of 2.
G of 2, okay? So we have to know what g of 2 is, right? How do I know?
You plug it in.
Okay, well,
You you can just set y equal to 2 because y equals x.
okay,
Bam.
right,
Not
because,
x.
okay,
Yeah.
because would you agree that the domain and the range are reversed, right? So if if, f of two, so, okay. F of two equals what?
8 plus 4 minus 1, so 13, 11.
11, is it 11? You got to figure it out, 8 plus, yeah, 11, right? Okay, so then what does this tell us about G?
It would be 11.
So G of 11 equals 2, right? You see what I'm saying? Okay, so what we need to do is we need to figure out, this implies that G of 11 equals 2, but that's not the answer we need to solve, is it? We need G of 2, right? We need to have something, a statement that's equivalent to G of 2 equals something, right? So how am I gonna set that up over here in F space? F of something equals 2, right? Well, I gotta figure out what the something is. Well, that's easy to do though. I'm just gonna go up to my equation and say, well, f of something equals 2. Find out. Set it equal to 2 and solve, right? So we end up with the equation then, x cubed plus 2x minus 1 equals 2. Well, let's solve it. What do we do?
Add 1 to both sides.
Okay, we add 1 to both sides. Well, no, we don't.
Oh, do we factor it first?
We're gonna have to put it in standard form, aren't we? Right? So we'll subtract 2 from both sides and we get the polynomial equation x cubed plus 2x minus 3 equals 0 that we gotta solve. Okay. All right, so how do we deal with that? This goes back to pre-calc, right? This would have been, so this is something you deal with in Algebra 2, but then you would deal with it more probably, further you deal with it in the pre-calc part of pre-calc trig.
Wasn't it like a minus b times a squared minus 2ab minus b squared, something like that?
Well, okay, so
There's a formula for it.
there isn't a formula for this one, right? You're thinking of quadratic formula maybe? What do you?
X
No, isn't there a formula to
equals
like,
negative b.
factor cubed root, not cubed roots, but, never mind.
Okay, so to find, so for cubic functions, you can factor it, right? Maybe. But this one, you're not gonna be able to factor conveniently, because this polynomial, we can't factor it by grouping, because we only have 3 terms, right? So really, the only thing we could do here on this guy to find these roots would be to use the rational root theorem, right? Assuming that we have some nice, convenient, rational number. If we don't, this becomes a pretty hard problem anyway, right? So what's the rational root theorem tell us? We're gonna take a list of possible answers and just check them to see which one checks off, right? The list of possible answers, if there is a rational 0 of that function, it has to be of the form a factor of the constant divided by a factor of the leading coefficient, right? So what's the leading coefficient? Okay, so the denominator is 1, which is good. It's going to be an integer if it exists. What are the factors of the constant? Is this ringing a bell? Ish. Solid-ish.
Real root theorem, is that what you said?
No, this is the rational root theorem. Okay? Is that kind of sort of maybe ringing a
I
bell?
loosely remember.
Okay. Well, let me just show you what's the way I can prove that to you, show you that. Let's do, okay, I got one. I got a way I can show this to you. Because this is kind of cool. You need to know this. So let's just say we have a polynomial in factored form. So it looks like this. A sub 1 times x plus b sub 1 times a sub 2 times x plus b sub 2 times a sub n x plus b sub n. This will work, okay? That's in factored form. Agreed? With n factors. Everybody get that? Okay, if I were to multiply this out, expand this out, would you agree I'm gonna get a whole jumble of terms, but what's the leading term gonna look like? The biggest power of x.
And have x to the n.
Yep, and what's gonna be the coefficient?
Factor one of them.
Okay, but wouldn't you agree that if I were to expand this out, let's
Factor
just
of
take
all
the
of them.
first two, right? I'm gonna end up with a sub 1x times a sub 2x. So I'm gonna get a sub 1 times a sub 2x squared, plus a bunch of other crap, right, that we don't care about. That's gonna be lower powers of x. When I distribute a sub 3 through to that, I'm gonna get a sub 1 times a sub 2 times a sub 3 x cubed, plus a bunch of other stuff, lower powers of x, right? Agreed? So when I go through that whole process, I'm gonna get lots of terms, lots of cross terms. But the leading term is always gonna be built from the product of the leading terms in each of the individual polynomials, the factors, agreed? So would you agree I'm gonna get something like this then? I'm gonna get a sub 1 times a sub 2 times a sub n, x to the n, plus a bunch of stuff, right, that I don't care about. And that's really, really shouldn't use a dot, dot, dot there because that's called, is that an ellipsis? Really shouldn't use that because I get what's the last term gonna look like? What's the constant gonna be?
B1 times B2 times Bn.
Right? Everybody agree? Okay. So let's reverse the process then. The zeros, what's the zero of this term gonna be? Right? Negative. Right? What's the zero of this term gonna be? Etc. Right? Aren't all of those zeros going to be rational numbers where the numerator is a factor of the constant and the denominator is a factor of the leading coefficient? So the rational root theorem works, right? Get it? So if we go back to this problem here, well, if I want to find all of the rational zeros of this, then x is going to have to be the set of possible values of x, rational values of x, is going to consist of factors of the constant divided by factors of the leading coefficient, right? Plus or minus. I mean, we don't know what the signs are, right? Everybody agree? So then x would be built from a list of plus or minus 1 or plus or minus 3 over, I don't need plus or minuses on the bottom because they're already included on the top, over 1 in this case. So I only get 4 possibilities, plus or minus 1, plus or minus 3, right? Get that? River, you get that? Okay.
I know the answer, I understand this.
Yeah,
I'm sleepy.
I
but
know, and
understand
that's,
it.
that's not a crime to be sleepy.
Yeah.
I just wanna make sure, I want you to get this.
No, I'm getting it.
So then if we go back to our problem, we could just try those out, and if the zeros are rational, we're guaranteed to get them that way. If they're not, we're stuck. Then we'd have to do something else. But these would be the easy ones. Let's get the low-hanging fruit first, right? So let's try this. We could just run through these synthetically. We'll make a list, right? So the possible values of x would be 1, minus 1, 3, minus 3, and we'll just check them off. So we'll run through synthetically, let's try a one, and our coefficients are gonna be 1, 2, up, 0.
For a second, I thought it was like a white hole in it, because you erased it.
And we'll just see if we get a 0 there, right? Now, do you guys know, so there's ways, do you guys know how to do, you've done a ton of this, right, of synthetic division.
You just, it's 1, and then 1, and then you multiply it by 1, so it's just 1 again, you drop 1 down.
Right, so we bring the 1 down, 1 times 1 is 1, plus 0 is 1, 1 times 1 is 1, plus 2 is 3, right? So it worked, right? Okay, so we found that 1 is a solution, okay?
It's the only one.
And yeah, it's the only one because look what we're left with, right? What we're left with here is the quadratic factor, x squared plus x plus 3. And we can show right away that that has no real zeros because the discriminant is negative, right? The part under the radical in the quadratic function, quadratic formula, is negative. That's fine, right? Okay, so if, look, this is just saying b squared minus 4ac is 1 minus 12 is negative 11, right? So we're gonna get complex zeros with imaginary parts for our other two, right? So the only real 0 is 1. And so what's that do for us then? We know that tells us we can now fill in the blanks up here. F of g of 2 equals what? Well, we found that f of what equals 2?
1.
1, right? So that's the same thing as saying g of 2 equals 1. You get it? Okay? Tricky, huh? So then now all we have to do is just differentiate this easy function here. Well, what is, this is really fun with these new colors. So what's f prime of x?
3x squared plus 1. 2.
So then f prime of g of 2 is just f prime of 1, right? So our answer is, this is all equal to 1 over
5.
f prime of 1, which is 5. Yeah. Okay. Okay, well, we could get really tricky with this. We could even say, I don't think the book does this, but let's do, okay, I got a really good one for you.
This one sees more colors.
Yeah, exactly. So there's more colors. So how about, I gotta pick a new function. I'm gonna let them pick a function for me. I don't wanna have to think about that part. Oh, yeah, they do one like this. This is cool. Oh, I love it. Okay, let's do this. Oh, this is so fun. Okay, so we got,
Wait a second. Mr. Oil, for physics, where are we gonna do the catapult, or the trebuchet battles?
ooh, trash can be done, huh? Yeah, we'll have to go somewhere else. We'll figure it out. We'll have to go, maybe we'll go,
Why can't you still use the trap?
It's gonna be tore up as of Tuesday.
yeah.
Wait, or, like,
So we just
Or
need a
do we do
flat,
track?
we just need a flat place.
With the gym work?
I did it in the gym last year.
I prefer not to use the gym. Prefer to go. It'd be that good to do
I
it
might-
outside.
Break something with my lead projectiles.
Yeah, we can't be doing that. So we'll go outside somewhere. We'll have to just find a flat place where
Why
you
don't you
guys.
Do
just-
a parking lot.
Yeah.
We could do a parking
That's
lot.
not flat, that's an angle.
Use the
What if
sidewalk.
you did a car?
I mean,
Use
we-
the sidewalk then.
We,
Buy the
we
sidewalk.
could, yeah, I think we could just use sidewalks, and and you're free to, I'll say this too. If you wanna bring like a piece of plywood, if you have wheels on your trebuchet that need to roll, I'm okay with you bringing a nice flat surface to place it on. So like, what if we could even do it on the grass or something, right? You just have to have something flat on which it can shoot.
Sure.
Okay, I'm fine with that.
Probably.
I'm honestly not 100% sure if ours is gonna work, and we may have to just whip up Erling's one real quick. Find, period.
Find tangent to corner
Curve.
Curve. Okay.
Okay, so that involves to find the tangent line, we need to find dy dx, right? Everybody
So
agree?
can we just do? Oh, I know. Aha. Nice. Well, you just find the inverse, and then you can find the tangent at that point, because the tangent's gonna be same on the other side.
Okay, so,
How did we use to find tangent? We used to find-
well, so tangent,
Well, you just find the derivative, and then you set the points in.
right, so we just need a slope and a point, right? So the point's given to us, but we need a slope, which is a derivative, okay? But how are you gonna find, so we need to find dy dx, but this is not given to us as a function of x.
So you just do
Right.
inverse.
So, yeah, we got some things we could do here, right? One thing we could do is we could take advantage of the inverse, the pairing between the relationship between the inverse function and the function, right? So if I wanted to solve this for y, well, the inverse of this function would be y equals x cubed minus 7x squared plus 2, correct? Right? Okay, so the derivative of the slope of this function, right, is going to be equal to the reciprocal of the derivative of the inverse function at the, you see what I'm saying, at the cousin value, right? Because we're gonna have to do what we did last time. We're gonna have to take, how do I articulate this, right? We have to take the value that's gonna make this function equal, yeah, this. I don't know how to say it.
We just take that.
When we want to plug, let's say we want to plug an x value of 2 into the inverse function, right? Well, that's the input value for the inverse, but that's the output value for f in this case. You see what I'm saying? Right? So we had to go back and say, okay, well, in other words, f of what equals 2, because the input of the inverse has to be the output of f. Right? See what I'm saying? Okay. Right? Right. And the input of f equals the output of g. Well, we don't even know what g is, right? So we can't directly find the output of g, right? What we have to do instead is find out what the input of f would be. See what I'm saying?
We should do this as a group.
So wrap your brain around this one then, right? There's something really cool I want to show you at the end of this too. Let's not even find the tangent. Let's just find dy dx. Okay, we don't have to even worry about the whole tangent. I just want you to find dy dx. Okay, at that point.
So we're not finding tangent at all?
I don't care if we find the tangent line. Let's just find we can talk about that later. Just find dy dx. That's the important part.
Are we gonna use the board?
Eventually, but I want you guys to come up with put your heads together and come up with your strategy on this.
I don't know, that's what we would do, but we just use the board so we can write and have everyone see.
That's fine, I guess. Yeah. Okay, so let me do this then. Let me just say, let me copy this whole thing, okay? Okay, there you go. But I do have to take roll first, because then I need to,
Okay.